So in this video, we're going to talk about power series. One thing you need to know about power series is they're an extremely useful tool for approximating and even defining functions. You can think of a power series as being like an infinite polynomial. So if we were writing out the terms of a polynomial f of x, we could write 1 plus 1/2 x plus 1/3 x squared plus 1/4 x cubed. Or we could use summation notation and rewrite this as f of x is equal to the sum from k equals 0 to 3 of 1 over k plus 1 times x to the k. A power series would be the same idea, but we just wouldn't stop at x cubed. We would keep going with this pattern. And so we would have 1 plus 1/2 x plus 1/3 x squared plus 1/4 x cubed plus ... The next term would be 1/5 x to the fourth and then 1/6 x to the fifth, but this never stops. So we have to use summation notation here. We'd write g of x is equal to the sum from k equals 0 to infinity of 1 over k plus 1 times x to the k. And the sum goes on forever, and the party never ends. Now you'll notice I was using function notation here. The question is, does it make sense to use power series to define a function of x? And the answer is yes, but only if that value of x makes the series converge. So when we have a function, we're expecting to be able to plug in a number and get a number. And if the series converges, then we get a number out. And if it doesn't, we don't. So let's look at a specific example. Let's define the function h of x to be the sum from n equals 0 to infinity of x raised to the n power. Now it's really helpful to remember here that when you look at this summation 1 plus x squared plus x cubed plus x fourth plus ... that if the absolute value of x is less than 1, then this is equal to 1 over 1 minus x. And if the absolute value of x is greater than or equal to 1, then this series diverges. So let's look at two x values and see, does it make sense to plug in? What is h of negative 1/3? Well, here we can plug it in. Since the absolute value of negative 1/3 is less than 1, h of negative 1/3 would be 1 over 1 minus negative 1/3, which is 1 over 4/3, which is 3/4. And then the question is, what is h of 2? Well, since the absolute value of 2 is greater than or equal to 1, this sum would diverge, and h of 2 would be undefined. So for this sum, h of x equals the sum from n equals 0 to infinity of x to the n, we can evaluate h of x at any x that's in the interval from negative 1 to 1, the open interval from negative 1 to 1, where the endpoints are not included. In other words, this power series, h of x equals the sum from n equals 0 to infinity of x to the n, defines a function of x whose domain goes from negative 1 to 1. So this is a taste of what we're looking forward to. We're going to be defining a wide variety of common functions using power series. And when I say common functions, I mean things like sine of x, cosine of x, e to the x, etc. We're also going to be using power series to define functions that don't already have quote-unquote names. So if you have a power series, you can just say, here's how I find my coefficients, and you can make that function up and see if it defines a valid function. And then we want to do what we just saw. We want to determine where these functions are actually defined, or what values of x it makes sense to plug in. So power series are a very important tool. We'll be learning more about them in just a moment.